It's pretty easy to build a bad Ethernet cable, but can you build one that's mostly bad? So here's what I'm trying to do. I'm teaching the new CCNA 2020 for CBT Nuggets, and I'm about to demonstrate the interface counters on these switches to show, how you can see if there's bad packets and all that sort of thing. And I had the idea, I'm like, I've never been able to show the impact of a bad Ethernet cable. I mean, it happens all the time in the real world, and when it does, it is painful because you're troubleshooting slow connectivity for days, and you're like, it's a bad cable. So my question is, can I build a cable that's bad enough to cause interface errors without going down all the way? A mostly bad cable.
Well, it just so happens that your friend here is only mostly dead.
So here's the theory. It's called unshielded twisted pair cable for a reason. Inside of this shielding are all kinds of twists and turns in the cable to make sure that it prevents interference. It actually kind of creates an electromagnetic field outside of the cable, so interference from the outside can't get in and inside can't get out, but also within the cable itself. The twists on the individual wires keep the wires from interfering with each other. So my theory is if I can strip off enough of the shielding to where I've got exposed cables and I can untwist them far enough, I can create a mostly bad Ethernet cable, one that produces all kinds of errors but still functions. So, fun little piece of knowledge, if you look at these Ethernet twists and you look really closely, you'll notice that they're all twisted a little bit differently. If you look at the blue and green, those are really tight twists and they're really tightly packed together. If you look at the orange and brown, you can kind of see there's a little more space between them, not twisted as tight as the other two. That's not a cable flaw. That's actually intentional. That actually keeps the transmission phases out of sync so that they aren't all in the same exact spiral as the other and they don't interfere with each other as much. So, I don't know. That seems long enough to do some damage. Let's untwist these guys, crimp them up, and see what happens. So there we go, 8 individual wires. I'm sure whoever created Ethernet is rolling over in their grave right now, even at the thought of this. Now, typically you would wire these to a standard, like T568A or B. B is the one that all human beings should use. Orange stripe orange, green stripe blue, blue stripe blue, green, brown stripe brown. Just create cables for a little while. You'll commit that to memory too. But in this case, it doesn't matter. I'm just going to go orange, orange stripe, blue, blue stripe, green. I mean, let's just follow whatever order I want. As long as it matches from side A to side B, we should be good. Let's find out what happens. If I can find the formula to build a mostly bad cable, this could be useful to test all kinds of things. I mean, there's all kinds of quality of service features, things like IP-SLA, where our devices run tests on cable to see if they're bad enough or that connection is bad enough, and then make adjustments to the routing table based on the relative badness of the cable. I'm like, man, if I could figure out how to build a bad Ethernet cable that I could use to test that in a lab environment, that'd be so valuable, because how many times do you configure SLA and you're like, well, I think that's going to work, but obviously you don't have a bad connection to actually test it with. You either have the connection that's up or down. Yeah. Isn't that the ugliest thing you've ever seen? Hang on, let me grab my cable tester. Oh no! Seriously? In all my excitement, I put the Ethernet connectors on the wrong way. I actually completely rolled the cable. Let's try that one more time. There we go. It actually turned out to be a lot easier to take the individual wires and shove them in there one at a time. A luxury you don't often get making a cable with shielding on it. Let's crimp it down. Snap and snap. Jury says, yeah, check that out. Passed. Now let's see if our little rainbow cable works. Well, sorta. All right, so here's what I'm going to do to test. I've taken us over here to the Nevada theme park. It's a long story. My kids got involved. I've connected a Synology device right here to this Cisco switch, and there's just a ton of data sitting on here. I'm going to take our Frankenstein cable and connect the Cisco switch here up to the production network right here. Now, my computer that I'm talking to you on right here, and I'm going to do a data transfer, lives on this switch. And I'm going to try and transfer data over that Franken cable to and from the Synology device, and let's see what happens. Now you can see I've got a console connection to the Cisco switch just so we can see if there's errors on the interface. I'm getting logged in right here. There we go. Here's my file. This is 3.5 gigs. It is currently stored on that Synology. I'm going to take that and drag it to my desktop. Yes, I know that this may be harmful to me, and I'll drag the copy window right here into the screen. That's actually better than I thought it would be. It's a 100 megabit per second switch, so that's about what I would expect to see. Let's do a show interface fast Ethernet 0/1, hit enter, and it's pretty good. We got a good data rate going on, and I'm not seeing hardly any errors at all. If I bend it around a little bit, kind of rustle its feathers. Do the show command again. I got nothing. What if I bite it? Show command again. I got nothing. My first test was pretty much a dismal failure.